Okay, so today we're talking about Chapter 7, Section 5, the vertex of parabola applications and modeling. Okay, so previously we had talked about completing the square, and it was kind of a long and tedious process. And I told you that when it comes to solving quadratic equations, that's always third on my list, right? I would much rather factor it in my head if I can, use a quadratic formula, and then honestly the quadratic formula takes care of everything. I don't have to do the completing the square. But I did mention that completing the square is necessary later on. And we're going to see why in this particular section. So let's go ahead and snip this. This might be pretty good for the notes. Alrighty. And so we'll just jump straight to example 1 here. And let's go ahead and snip this thing, give it its own page. Alrighty, so example 1 reads, writing a quadratic function in the form f of x is equal to a times the quantity of x minus h squared plus k, where a is not equal to 0. Okay, now obviously the a not equal to 0, that's just there because, well, if a was 0, then it wouldn't be a quadratic. Okay, so don't get confused by that. But anyways, so we have our function, given f of x is equal to x squared plus 8x plus 13. It reads, now a is write the function in the form f of x is equal to a times x minus h quantity squared plus k. All right, so how do we do this? Okay, so the way we have to go about doing this is we're going to have to complete the square. Okay, but we're also going to be a little clever about it, and we'll see the cleverness really in example 2 or 3. But this first example just kind of gets acclimated to it. So the first thing we need to do is we just have to kind of remember the completing the square. And if you need a refresher, you can go back and check out that video. But let's go ahead and write this out. Let's put it in. Yeah, we'll keep it white, I guess. So f of x is equal to x squared plus 8x plus 13. Okay, so we need to figure out how to change this function into the quadratic that we're used to and put it into this form right here. Okay, so what we're going to do is we're going to complete the square. So let's go ahead and erase this little bit there just for right now. We're just going to erase it kind of. Let's go ahead and really drive the point home here. Okay, and then we'll put plus 13 over here. Okay, so all I basically did, if you, I mean, of course you saw, but I just basically moved 13 to the side, and now I'm just looking at just what's inside here. Okay, and obviously there's nothing right here because we're going to put something there. Well, if you recall, this is kind of set up in the way that we want to complete the square, right? If you recall, it was half the quantity of b, so half of 8, which is 4, and then we square it, which would be 16. Okay, so what we're going to do is we're going to put a plus 16 right there. Okay, but for the sake of this, and because I like using our a little algorithm because it helps us, well, it kind of tells us really in the second step what the factored form is. So let's go ahead and put that over here. So my 0th step, if you recall, was just the formula. My first step, I plugged in my b value. My second step, I went ahead and halved it. And then my third step, I did the squaring. Okay, so this 3 is not coming out very nice. There we go. Alrighty, so what is my b value? Well, my b value again is 8. 8 divided by 2 is 4. And 4 squared is 16. Okay, so what I'm going to do is I'm going to put a plus 16 right there. Right? So where's the cleverness come in? Well, I basically just added 16 to my function, didn't I? I mean, we're told, what we do to one side, we have to do to the other, but we don't really have another side over here, do we? No, we just have the name of the function. Okay, so what must we do? Well, I am 34 years old. Okay, and if I were to add 16 years to my age, all right, uh, in order for that to be a true statement, then I must also subtract 16, right? So that's what we're going to do. We're going to, we add 16, so we're also going to subtract 16. So let's go ahead and rewrite this function in factored form. Now the factored form is going to be what? Well, it's going to be over here at step 2, right? Because we've done this complete and square before. So we're just going to look at that number there. So it's an x, and then that's a positive 4. So we're going to say plus 4, and then quantity squared. Okay. And then we have the plus 13 out here. All right. Well, we added 16 to the function, so we must also subtract 16. Okay. So we must also subtract 16. So now my function looks like this. F of x is equal to x plus 4 quantity squared, and then minus 3. All right. And there we go. We have now changed the function. Well, we essentially rewritten the function in our vertex form. Okay. And then B wants us to identify, so this is A. So B wants us to identify the vertex, axis of symmetry, and minimum function value. So what is the vertex? Okay, so V, the vertex, I guess we can just put equal sign. Okay, well, all right, again, the vertex in this particular case is going to be a negative 4 and a negative 3. Okay, the axis of symmetry, well, that's going to be negative 4, so we'll put semicolon there. We'll put axis. We'll just put A for axis of symmetry. All right, the axis of symmetry, well, that would be a colon here, is going to be x is equal to negative 4, right? Just the x value. And then minimum function value, well, the minimum function value is going to be a negative 3 because we see that we go down here to negative 3. Okay, so the minimum value, and we'll put minimum here, is going to be, how should we write that? I think we just put negative 3, honestly. So we'll just put minimum negative 3. Okay, because that is the minimum value of the function. Right? So that's how we do that. Now we're going to do another example. How did they do that? The minimum value. Okay, yeah, they just wrote the minimum value is negative 3. Okay. All right, so now we're going to get a little clever, a little bit tougher as well, but we can handle it. We've made it this far. We're almost done with the semester. All right, so I'm going to go ahead and mark off a spot so I can do my little algorithm over here. So these threes, they just don't work well when I write them small. Alrighty, so this reads, example 2, given f of x is equal to negative 2x squared plus 12x minus 16. Okay, so if you recall, the very first step we have to do whenever we did complete the square was we had to have a 1 in front of the x squared. Okay, well in this particular case we have a negative 2, so let's go ahead and write our function like this. I'm just going to rewrite it, so I'm not really rewriting it like anything. So okay. So the same thing I'm going to do. I'm going to do like we did in the first example, except for I have to do one step first. Okay, and that step is going to be I'm going to be factoring out a negative 2, but just from the first two terms. Okay, because I'm going to leave that last term alone. All right. So we're going to factor out a negative 2 here. That leaves us with a positive x squared minus 6x, and we have a minus 16. Okay. All right, so the whole point of this, again, is to make sure that I have a 1 up here in front of the x squared. Okay, then I can begin completing the square process. And what colors I went? Blue, yellow, red. Okay, so blue, my b value is a negative 6. All right, negative 6 divided by 2 is a negative 3. and then negative 3 quantity squared is going to be a 9. Okay? So this function is going to end up looking like, and hopefully we'll have space. So, so we have the negative 2, then we have x squared minus 6x, and then we have a plus 9 right in there. Right, and then we have a negative 16 or minus 16 there. Okay. Now, unlike the first example, all right, the first example, we know that we added 16 here, right? We added 16 to the problem, therefore we subtracted 16. Okay. This time we added 9 to the equation. All right. But it wasn't actually 9. And the reason why is because it's a 9 times a negative 2. Okay, so what we're actually doing is we're subtracting 18 from the problem. Okay, so let's go ahead and recap here. We did do 16, and then right here is a 1. Okay, so it is 16 times 1, which is a positive 16. All right, and since we added 16 to the equation, we subtracted 16. Okay, in this particular case, we have a negative 2 times a 9, so we are subtracting 18. Therefore, we must add 18. Okay, therefore we must add 18. Okay. All right, now let's go. We'll go and put this in factored form. All right, so it's going to be a negative 2, and then the factored form here, again, is just simply going to be step 2. That's a negative 3, so it's going to be x minus 3. I'm going to try to color coordinate so we can see exactly where these numbers are coming from. And then squared. Hopefully I put squared on this. Okay, good. And then a negative 16 and a plus 18, well, that's just going to be a plus 2. Okay, so that was A. Again, I'm kind of slacking here. That's A. All right, B, find the vertex, axis of symmetry, and maximum value. Okay, so, excuse me. All right, so we're going to have a maximum value here because, well, it's a parabola opening downward. So anyways, B, my vertex is going to be equal to, looks like a positive 3 and a positive 2. My axis of symmetry, pretty sure I did. Yeah. My axis of symmetry is going to be x is equal to negative 3. And my maximum value, my max, right, is going to be 2. Okay, what if I put, there we go, 2. Okay. Next up, we're going to find the x and y intercepts. And of course, the x and y intercepts are, I mean, I dare say, kind of easy. So let's see. I probably just have to go ahead and put this on the next page. Let's go ahead and do that. Okay, so C is to find the x and y intercepts. Well, let's go ahead and find the y-intercepts first. The y-intercepts are pretty easy, or very easy, right? Because what I do is and looking at this equation, I just put a 0 for x everywhere, and that takes care of that. That takes care of that. So my y-intercept is just going to be negative 16. So y-intercept is, I don't know if I said x equals 16 or I meant y is equal 16, or in other words, 0, negative 16. Okay. Now my x-intercepts are going to be a little different, and obviously, so we're going to have to do, looks like we can factor it. So if we factored this, it looks like we can say negative 2, and I'm just going to kind of do scratch work down here and then put the x-intercept up here. So let's go ahead and get that ready. Okay, so my scratch work down here, we can factor out a negative 2, and we've got an x squared plus 6x minus 8. All right, and this is pretty easily factorable. It factors into x minus 4, x minus 2. Okay, and so these are my x-intercepts, positive 4, positive 2. So my x-intercepts are 4, 0, and 2, 0. Those are x and y intercepts. And then the graphing of it, I'm just going to go ahead and let the textbook graph this. All right, of course, that's just using all the information we have. The vertex, the axis of symmetry, and the intercepts. We end up with a function, a graph rather, that looks like this. Okay. Okay, so next up, next up we're going to have something super duper 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 easy. And let's go ahead and we'll just put this on a page. Okay, so some explaining here. Um, all this, all this is basically showing us over here to the left is how we derive our vertex formula. Okay, so our vertex formula. Now, if I were to, and I mean I did, I still do, I guess, memorize one of these, which you're going to have to. It just makes life so much easier. What I would do is memorize the one on the right. Okay. Now the formula is negative b over 2a. I don't think is that hard to memorize. I think it's just one of those things you look at. You can commit it to memory pretty darn quickly, I think. But it's negative b over 2a. Now, before we go on, all right, let's look at this. All right, it's in the form of x, y. Right, it's a coordinate. It's a point. Okay, so it's a point on a graph or on a plane rather. The x value is going to be the formula of negative b over 2a. The y over here is the function at that value. Of course, we're used to seeing that. We've seen it before. I mean, we see it all the time, rather. Okay, and we see it all the time as x and f of x. And that's all we're seeing here. We're seeing x and then f of x, right? In this case, it is negative b over 2a and then f of negative b over 2a. Now, I know as a student that probably didn't, resonate too well with you. So let's do an example because that's how we learn. Okay, so for this, excuse me. So for this, we have our function h of x, all right, and a reads use the vertex formula to find the vertex. Okay, so in order to find the vertex here, we're just going to use our vertex formula, and I guess we can go ahead and let's write it up here. Okay, that's not really that pretty at all. Okay, so that looks a little better. Alrighty. One moment. Let me get me a spider. I don't really like killing spiders too much, but that's just that's life. Alrighty, so use the vertex formula. So, alright, looking at our equation. So let's go ahead and write our equation out so we can really understand what I'm looking at here, what the negative b and all that stuff means. Okay, of course you probably already know, but I just want to be super duper thorough. Okay, so in this case, this is the a, which is a 1, right? This is a b, which is a negative 2, and 5 is the c. Okay, so I was hesitating. I don't know if I should put a 1 there or not. Yeah, we'll put a 1 there just to really drive the point home that a is 1. Okay, so using the vertex formula, it's negative b over 2a. All right, so how do I go about doing negative b over 2a? Well, it's just easy. So it's a negative b, so it's a negative, and then b is a negative 2. So negative 2 all over 2 times a, which is 1. Okay. Well, negative 2 is a positive 2, 2 over 2, or in other words, 1. Okay. And this is negative b over 2a. All right. So 1 is going to be in my x position. Okay. So I'm just kind of, let's put a little arrow here, kind of point out that what we're doing here. And next we're going to do f of 1. Okay, because we have the 1 here that we derived from the negative b over 2a. So we're going to do f of 1. Okay. Well, what is f of 1? Well, f of 1, we're going to, it's not f of 1. Okay, sorry, it's actually h, right? So got to be careful with notation. Okay, I say that because the function's name is h, and that's the actual name of the function. So we're going to abide by that. So we're going to put 1 in for x. So we have a 1 squared minus 2 times 1 plus 5. Well, 1 squared is 1 minus 2 plus 5, which is equal to negative 1 plus 5, which is 4. So 4 is the y coordinate. All right. And I don't know about you guys, but I much prefer doing this to find the vertex than that completing the square stuff we did for the first two examples. Okay, so for 1, or rather for A, that is the vertex. Okay. And then for B, we want to find the x and y intercepts. Again, so the x and y intercepts, the y intercept is always the super duper easiest. So y intercept is just going to be, again, looking at this function. You put 0 in for x, so that goes away, so it's just 5. So 0, 5 is the y-intercept. And the x-intercept, okay, well, it looks like we can, oh, this is unfortunate. We can't necessarily factor this too easily. By too easily, I mean we can't factor this. So what I'm going to do is I'm going to go ahead and put this in my handy dandy calculator. Okay, so I've got a 1 plus or minus 2i. So this tells me that since we have, again, to find the x-intercept here, we just use a quadratic formula. But since I want to keep everything on one page, we know how to do the quadratic formula. So I just went ahead and did it on my calculator. So since my x-intercepts are imaginary numbers, right, 1 plus or minus 2i, we know that we don't actually cross the x-axis at all, right? So all we have is a y-intercept, and as usual, we're going to go ahead and let the textbook do the graphing. Okay, there we go. And of course, we do indeed see our vertex at positive 1, positive 4, my y-intercept at 0, 5, and then we just connect the dots here. Okay, and of course, we don't cross the x-axis because, like I said, our x-intercepts are 1 plus or minus 2i. All right, and next up we're going to be applying our quadratic formula. Okay, so again, I might say this too much. I don't know. Again, I teach a lot of classes. It's hard to keep up, but even then, it's not a bad thing to say, because when I was taking this course, I wasn't going for mathematics. I was going for psychology, but eventually started to like math and got pretty darn good at it. But my thought process when I first took this class, if I were to see this kind of problem on a test, I would think, okay, well, I hope there's a lot more questions on the test because I'm not doing the word problem. Now, at the same time, I don't know if that's normal or if I was just a particularly lazy student. But my point is this: don't be old me. It's not hard. These problems are basically the exact same as the examples we have been doing. It's just we put them into an application. So anyways, so the crew from Extravaganza Entertainment, starting up here, launches fireworks at an angle of 60 degrees from the horizontal. Okay. So the height of one particular type of display can be approximated by our function we see here. So where h of t is measured in feet and t is measured in seconds. Okay, so again, h we have being the height in feet, and t is in time in seconds. So how long will it take the fireworks to reach their maximum height round to the nearest second? Okay, so in order to figure out the maximum height, we just have to find the vertex. That's it. Um, and so let's go ahead and, again, let's go ahead and rewrite our function here of negative b over 2a, and then the function at negative b over 2a. Okay. All right, so in this particular case, let's go ahead and mark this as a. So what is negative b over 2a? Well, we're going to have, in this particular function, we don't even have a c. We have an extraordinarily ridiculous looking b. So it's going to be a negative, and then my b value is 128 on the square root of 3. My threes, there's not the best. 3t. Okay, that's negative b all over 2a. Well, 2 times a, which is negative 16. Oh, I didn't mean to put a t. I don't know why I did. Just got a little carried away. Again, these variables have nothing to do with the a, b, c terms. We're just looking simply at the value in front of them. So 2 times a negative 16. Okay, so we want to figure out how long its maximum height. So in order to do this, we have to figure this out. So, all right, let's put this in our calculator. So it's going to be a negative 128 on the square root of 3. So 128 on the square root of 3. And that's going to be divided by negative 32. So we end up with a 6.9. How much is one? Nearest second. That's 6.9 should do. So 6.9. Okay. So again, that is this value here. Next, I'm going to do the function at 6.9. Okay. So what is the function at 6.9? Well, we're going to do h of t. So it's actually not of t, it's actually h of 6.9. I've been making that mistake quite a bit lately. No big deal. So that's equal to negative 16 times 6.9 squared plus 128 on the square root of 3 times 6.9. Okay, so as ridiculous as that looks, let's put that into the calculator. Whew, okay, so 768. So 768. So my vertex here is going to be at 6.9 and 760. I wanted to say 8. I don't know why I wrote 7 there. So that's my vertex. And so how long will it take for the... Actually, I did A and B actually just right there. So A, how long will it take for the firework to reach its maximum height? Well, it's going to take 6.9 seconds, right? Because that is the x value, right? Or in this particular case, the t value, sorry, time. And then the height, all right, well, again, we just did B. Well, the height is 768 feet. Okay, so that was it. So we accidentally did both of them in just one little motion there. Okay. And I can't remember if I did example 5, and I think I'm going to go ahead and do it just in case. But it's not. I can't remember if we put it in the homework or tests. Oh, so if we start up here, okay. Um, so we're going to go ahead and do it. If it's not needed, no big deal. At least it's here, just in case. So example 5, there's not really not much of an introduction here, but I don't know how to put it. There's not really much of an introduction here, but what we're trying to do is we're going to be solving systems of well, these aren't linear equations, solving systems of equations. And the way we solve systems of equations is, again, I feel like this textbook really just jams us in here with let me go back and check this out. All right, so this is the only introduction here. In example 5, we will learn how to write a quadratic model of a parabola given 3 points by using the system of equations in the standard form. This process involves which we'll do. Okay, so yeah, there's not really much of an introduction here, and that kind of uh, that's not good. But we'll just go. Well, again, I'll assume that the authors know what they're doing. So what we're going to do is we need to write a system of equations. So in order to do this, we're going to make substitutions here, and the substitutions are pretty straightforward. Okay, we have 3 points here: 1, -1, -1, -5, and +2, 4. All right. Well, my quadratic equation. All right, because again, it says write an equation of a parabola. Okay, so think about this. So my quadratic equation is y is equal to ax squared plus bx plus c. And actually, let's put that in yellow because I like to put my equations up there. So it's equal to ax squared plus bx plus c. Alrighty. So we're going to have to make 3 equations, and probably shouldn't have put that in yellow. Dadgummit. Okay. We're just going to have that there for right now, but we're going to make 3 equations, and I wanted to make these different colors. That's my confusion here. Or not confusion, but that's my hesitation here. So my first equation, okay, or my first point is 1, -1. The positive one corresponds with the x, and the negative one corresponds with the y. And so it's as easy as you think it is. So we're going to say, and we're just going to, well, we'll start off right now writing it kind of backwards. No, I got to put that in white. I have to put this in white. Okay, actually, I got a better idea. Okay, sorry, haven't actually thought this through. So we have y is equal to ax squared plus bx plus c. Okay, well, we know that we can essentially rewrite that backwards, right? We can say ax squared plus bx plus c is equal to y. Okay, so we know we can write it. You know, all we did is basically write it backwards. So let's go ahead and erase this, and then let's try to maybe proceed because I was trying to get my thoughts in order there. All right, so the first equation, all right, we're going to put a 1 in for an x, so we're going to say a and then 1 squared plus b times 1 plus c is equal to my y, which is -1. Okay, well, we can clean that up, and it'll just be, let's, let's put this off to the right here, actually. Okay. So we can clean this up, and it'll end up being, again, just squaring the ones and things like that. It'll just be a plus b plus c is equal to 1. Okay, so that's the first one. The second one, we'll make it blue, is going to be a times a -1. And again, I'm looking at this point here now. A times -1 squared plus b times a -1 plus c is equal to -5. Okay? Again, just looking at this point. And so this ends up being, so a -1 squared is just going to be 1. So we have an a, and then we have a minus b plus c is equal to a -5. And then lastly, we have this point here, 2, 4. So we're going to say a times a +2 squared plus b times a positive 2 plus c is equal to 4. Cleaning that up, we have 4a plus 2b plus c, and that's equal to 4. Okay, so again, all I did was use these 3 points. Right? I'm trying to color coordinate so we can see exactly what we're doing here. And from here, we now have 3 equations with 3 unknowns. Okay, so 3 equations with 3 unknowns is unsolvable in itself, except for the fact that we have some tools here, and these tools we have is just going to be what we call elimination method. Okay, so we're going to kind of eliminate this using a system of equations. So first thing we're going to do, okay, is we're going to look at the 3 of these problems, look at 3 of these equations, and we're going to just basically compare 2 of them together and cancel out a variable. Okay, well this one is should be pretty simple to see, well, if you know what you're doing, I guess. And it looks like we have a plus b here and a minus b here. So what I'm going to do is I'm going to put them on top of one another. Okay, so we have a plus b plus c is equal to 1, and then a minus b plus c is equal to a negative 5. We're going to put them on top of one another and just basically do the arithmetic. Okay, this is interesting. It might actually be easier if I multiplied one of these by a negative number, right? So let's actually do that. So we're going to multiply this equation by negative 1. Okay, and so by multiplying by negative 1, I'm going to have a negative a. We're going to have a from a negative b to a positive b, and then minus c, and that's equal to a positive 5. Okay, so I multiply that by negative 1, and by doing that, this cancels, so we end up with a 2b is equal to 6, or in other words, we have b is equal to 3. Okay, and b is equal to 3 is a big deal because now we have the value of one of our equations, or I'm sorry, one of our variables. Okay, so next thing we're going to do is we're going to try to figure out another variable, so we're going to have to cancel some other variable out. So what we're going to do is we're going to try to figure out what either the a value is or what the c value is. Okay. So next up, we're going to look at these 2 equations. All right. So what I'm going to do is I'm going to basically do the exact same thing, and I'm going to multiply. I'm going to multiply the bottom, or multiply this red one by a negative 1 to cancel out the c's. So let's go ahead and let's erase what we have right here, and we'll move this b equals 3 somewhere. Let's put it down here for the time being. Okay, so we have, the blue equation is a minus b plus c is equal to a negative 5, and then I'm going to multiply this equation by negative 1 and put it under it, so it's going to have a negative 4a minus 2b minus c, that's equal to a negative 4. Okay, and doing the arithmetic here, we have a negative 3a minus 3b, the c's cancel, is equal to a negative 9. Okay. All right, lucky for us, we know what our value of, how did I get b is equal to 3? B should not have been equal to 3 because we don't have 9. All right, real quick, let me look at this real fast. We have a negative, positive. Oh yeah, okay, so yeah, it's supposed to be 2. Sorry, I don't know why I put 3. Yeah, 6 divided by 3 is indeed 2. Okay, so there we go. So anyways, I've got a negative 3a, looking here, I've got a negative 3a minus 3b is equal to negative 9. We're going to substitute in b is equal to 2. So we have negative 3a minus 3, and like I said, we're going to substitute in that b value now. It's equal to a negative 9. So doing the arithmetic here, I've got negative 3a minus 6 is equal to negative 9. If we added 6 to both sides, we have negative 3a, and I can move my toolbar here. I don't think you can see it on the lecture, but here we go. So I've got negative 3a is equal to a negative 3, and so this tells me a is going to be equal to 1. Okay, so let's go ahead and erase all this now. All right, so we have what my a is equal to, and we have what my b is equal to. So now we have to figure out what c is equal to. Well, it's so much easier now to figure out what c is equal to by just simply substituting these values back in. So we're going to plug it back into this equation. So we're going to have, again, my a is equal to 1 plus b, which is equal to 2, plus c, and that's equal to 1. So we've got 3 plus c is equal to 1. Subtract 3 from both sides, so we have c is equal to a negative 2. Um, hmm. Okay. Okay. So, one moment. That's supposed to be a negative 1. Okay, it's supposed to be a negative 1 because it was a simple mistake on my part. Let's go back and look and see where that mistake was. The mistake happened here. I forgot to put a negative there because my y value here is a negative 1. Okay, so my x value was indeed 1, and my y value was a negative 1. That didn't affect any of the computations so far, luckily. So instead, so let's go ahead and do that again. I knew that didn't sound familiar or sound right. So we have, again, we're going to plug my a and b values in to that equation. We're going to do it correctly this time. So we have a 1, and then we're going to have a plus 2 plus c is equal to a negative 1, with 3 plus c is equal to negative 1, and we subtract 3 from both sides, so we have c is equal to a negative 4, and that sounds about right. So now we have a is equal to 1, b is equal to 2, and c is equal to negative 4. So looking at these three equations, the system of linear equations, well, it's not linear, I don't know why I keep saying linear. The system of equations, we're able to figure out what every single point, or what every single variable is by just simply looking at these 3 points. And of course, this is the equation of, well, this isn't yet. The equation of the variable, or the parabola, will be x squared plus 2x minus 4. All right, and let's move that over to the right a little bit and fit in an f of x. Okay, so there we go. That is the equation of a parabola that passes through those 3 points that were given in my equation, or my problem rather. Okay, I'm pretty sure that's it. And it's really weird that they put that there in this section. Oh well. That concludes today's lecture.